Here we're going to take a look at proving that congruent parts of congruent figures are congruent. It's an awful lot of congruence. And we're going to take a look at this through some examples. The first example is triangle ABC is congruent to triangle DEF. And here's our two triangles. And we see that AB is equal to 2.6, AC is 3.7, and angle C is 42 degrees. We have DEF where angle E is 65 degrees, angle D is 73 degrees, and we don't know what angle F is, but DF is 3.5. So what we need to do is figure out first what angle F is. I know that all angles combined are 180 degrees. If I subtract 73 and 65 from that, I find the missing angle F is 42 degrees. That's the same as angle C. So this shows me that the side opposite of F, since they are congruent and have same side lengths, the side opposite of F, DE, is going to be the same opposite from 42, which is 2.6. This means that across from 65 degrees is 3.5. Well, the unknown side here is 3.5, and that is BC. And that angle A is 65 degrees. So angle A is congruent to angle E. This leaves us with 73 degrees for angle B, and it leaves us with 2.6 for side EF. Showing that they're congruent and being able to match them up in that way is very easy for us, in that it allows us to quickly transfer some of these measurements. Now, if we were to look at the next example and hold the same condition being that triangle ABC is congruent to triangle DEF. So what I know when I look at that is that 180 degrees is the total of the angles. And one angle is 5y plus 1 plus the other angle of 6y plus 2 plus the third angle of 83 means those are all equal to 180. So I'm going to combine like terms here, and I'm going to have an 11y plus 86 is 180. So when I subtract 86 from 180, I get 94. That means I can divide both sides by 11 to figure out what y is. Y is approximately 8.545, and then it's going to become repeating. Now I'm going to go ahead and use that to be able to just figure some of that out. But if I take that number times 6 plus 2, then I can find that angle D is approximately 53 degrees. So that's going to give me a nice point here. I know that this right here now, oops, no I don't. That means that F, angle F, is my 5y plus 1. So if I take that 8.545 times 5 and add 1, I get about 43 degrees, or we'll call it 44. It's 43.7 and a quarter. So about 44 degrees. That is this angle B. So the good news is I have now a side, and across from my 44 degrees is 5x, but it is also 25. So 25 is equal to 5x, meaning x is 5. So if I'm trying to find what my missing side length is over here, 5 times 5 is 15, plus 8 is 23. And I can go back and fill in all of these values, but what I'm trying to do in this point is use the information provided to show that I can prove the values of a missing variable. But what if we talked in a little more general terms? What if I had to prove that ST is the angle bisector of angle VSW if SVT is congruent to SWT. So if these two are congruent, I want to try and prove this, and knowing that these two are congruent, this means that corresponding parts of congruent triangles are congruent. Or CPCTH, I don't know, they always put different letters into books, but corresponding parts of congruent figures are congruent. Very simply meaning this side is the same as itself, this side is the same as this side, this side is the same as this side. Now I don't know anything other than that on my side lengths, but I don't need any more. I do know that this angle is equal to this angle, corresponding parts of congruent triangles. This angle is congruent to this angle, and so this angle is congruent to this angle. That is the definition of an angle bisector, that there is a line with an equal degree, an equal amount of rotation on both sides. So we've gone to the definition of an angle bisector to be able to prove that ST is the bisector of VSW. So that's the definition of an angle bisector. It becomes really important to know the language in math that we're talking, because it makes the ability to prove things much more natural, opposed to having to look at this and we may look at it as a reflection, but we weren't provided with anything. So as a picture, the only thing I would have been able to tell is that ST was equal to itself. Once I knew that the two triangles were equal to each other, that they were congruent, I know that corresponding parts, and I'm able to apply that definition. If this video has been helpful, please like or share. And if you have any questions or comments, they go below.